While Justin's setting up his screen sharing, I'll just give a quick introduction. Dr. Justin Perry is the research manager at NAILSMA, the North Australian Indigenous Land and Sea Management Alliance. Lucky enough for me that I get to work with Justin in our day-to-day jobs. He's going to talk to us today about automated analysis of photos for environmental impact assessment. He's got a bit of a biography here. So Justin's based in Townsville, as I mentioned, heads up our research unit and is also my chief problem solver. I'll leave it to Justin. Thanks again, mate.
Thanks, Ricky. The sec that am I off mute? No, I'm not. Or am I? Yep. Okay, so thank you. Again, like the other two presentations, I'm going to try and bring this back down to how we actually embed this stuff into operational contexts. I've got a little thing here called Healthy Country AI that we're kind of starting to use as our banner, or as how we explain how we're doing a lot of this stuff. There's a link up there to the Git repository, so if anyone's interested in the software side of it, they can download that and descriptions. But I'll shift through. The way I'm going to talk about this today is how do we use similar approaches to how Andrew and Chris have been talking about this stuff around you're going to get lots and lots of information. How do you make it useful to look at impacts of feral pigs? And I'm going to use a couple of case studies to have a look at that. So I'm going to focus on Cape York Peninsula and the Archer River Basin. So in central Cape York, we've been working for the last 10 years, tackling some pretty serious feral pig issues, including at the time of starting this work, there was 100% predation on olive ridley marine turtles, which is a threatened species of marine turtle on the west coast of Cape York, and pigs cleaned up about 98% of those. So it was a really serious problem, and it caused some areas to be incredibly depleted or close to local extinction. So we've been, over the last 10 years, been trying to come up with solutions for monitoring and management and putting those two things together. So today I'll talk about tracking the impact of pigs using image analysis, which is just one element of what we've been doing. The challenge we have here, like everyone else that's spoken today, is about creating useful data. So it's not about going out and collecting lots and lots of data. It's saying, what are the useful bits of data that we need to collect so that we can spend less time monitoring and more time on targeted management. But also then understanding how that management is linked back to the impacts and the values that we set ourselves. In the example of the turtle management, we started with a 100-kilometre stretch of beach on the west coast of Cape York. About 50 kilometres it was easy to access, well, not easy, but you could get there. The other 50 kilometres would require a reasonable expedition to actually get there. So you'd be up for at least 4 days and a lot of money to access the other 50 kilometres of beach. For the 50 kilometres of beach that we were looking at from on-ground research, we knew that there's close to 100% of pig predation. So we really need to understand that as a critical conservation program. How do we actually know more about this beach, where the problems are, and how do we get that data quickly rather than the very, very difficult way of doing this on the ground. As with most of the parts of the world out here, this is a very big property. So there's close to 1 million hectares that the APN rangers look after. And so there are helicopters that get used regularly for work out there, be it burning, feral animal control, or mustering. So we actually came up with a method of attaching a camera to the bottom of it, and we did a bit of testing, and we collected 5 days of survey using a helicopter, which across that 100-kilometre stretch takes about 2 hours per day. This led to a lot of photos. We got 14,000 or over 14,000 geocoded photos. It leads to a lot of data, 27.8 gigabyte of data. So when we actually sat down and said, can we make something useful out of this? We did that manually to begin with, like everyone else. And that took 4 months of data preparation, 2 weeks of analysis, and that was done by 3 trainees and 1 postdoc. So as a useful management method, it doesn't really stack up. You'd need so much time and energy to actually make any sense of that data that you may as well go out there and record things on the ground or spend your money another way. So we had all of this information, and we decided to see whether we could automate the process. We started working with several different entities, mainly Microsoft engineers, and we came up with a software architecture that enabled us to take the survey images from the chopper, put it onto a computer, the ranger base, and then automate the process from that point forward, and then come up with a series of reports and interactive dashboards that would make sense for making decisions. So that's sort of a simple diagram of that software. And I'll just go into steps and how this looks as a workflow for a ranger. So when you're a ranger, you're going to be looking at the values. So what we always started with is what's the thing you care about? Now, in the case of the marine turtles, feral pigs, and other predators' impacts on marine turtles, it was we need to stop that predation and keep it under 30%. So when we're back at the ranger station, we're using maps, we're using local knowledge, we're talking about where those pigs are, where you think they are, which ones are impacting, which parts of the beach do we need to look after, and how might we go about doing that. And that sort of sets the area of interest. So where are we going to survey? It also sets the values. What are the things we actually care about? So we set ourselves some of those thresholds. All right, we want to reduce impact predation to less than 30%. So only 70% of those baby turtles need to make it to the ocean, or nests need to hatch, and those turtles need to make it to the ocean. That then sets the workflow for how we go about collecting that data. And so there's boxes around stuff that's set up to do some drone work. So this is for a different reason, which I'll talk about later, which is to collect information about wetland impacts. But for the turtle one, basically once you've selected your sites, you can go out and survey that site using a helicopter. That's just attaching a camera to the bottom. Once you've flown 5 days of survey, you'll have thousands of photos on an SD card. The next workflow is to copy the photos from the SD card to a OneDrive folder. And there's a good reason for doing that, which I'll discuss later. That then kicks it back off to this open dashboard section, to this upload raw photos to OneDrive. And as you can see here, that in the green listed below, a whole bunch of automated processes kick off in the background. And there's lots and lots of information. I could spend the whole talk talking about what happens in the back end. But really what happens is, from a ranger's workflow perspective, once those photos are uploaded into OneDrive, the next step is you get an open dashboard. The data automatically flows through the system, is analysed, is put into a database, and is thrown back up to a Power BI dashboard. This shows where the turtle tracks are, where the predation are, where the predator tracks are, and it puts it onto a map which you can interact with and have a look at. That enables the rangers to plan what the actions are, to implement the actions, and most importantly, to log those actions on another app. So once you go out there and decide that you're going to do something about it, you need to actually then say, all right, we put a cage over the nest, we shot some pigs, we put up some fences, or we did some 1080 poisoning. Whatever that action is, you need to log it so that you can start comparing your actions with the values you're trying to protect, and how those resources have led to changes in the value that you care about. So there's a little video here that shows really what the ranger sees after they've put the photos into the OneDrive folder. It's a visual representation of those photos that say, this has been predicted to be a turtle track or a predated nest. This is where it is on the area that you're looking at. And so here we can see some pig diggings on the beach. We can see some turtle tracks, some predator tracks from goannas, and you can see the impact of pigs. So we know this becomes an important area where you need to spend some resources and time. So really the important information is, where are your predator tracks, where are the predation events, and where are the turtle tracks? Those three things together are the decision points you need. Tracking them across time is what enables you to see how your impact, your management intervention is leading to changes. So that's for turtle tracks. So the second thing that we wanted to do was look at the impact of feral pigs on wetlands across time. Now, this is probably a much harder thing to do. Out there, there are probably about 1,000 different discrete wetlands spread across, like I said, close to 1 million hectares that we're actually surveying. So, and there's really only one road that runs down to the coast. So if you want to actually look at the impact of feral pigs on wetlands, you only get a very small snapshot. And often that's done with quite laborious traditional methods, survey methods. And you get sort of a small snapshot for when there's an expert there to measure it. It costs a lot of money to do that. So what we got here as far as the things that we're looking at is several methods that we could use to automate this process again. One of them is drones that you can see here. So we're dealing with, again, hundreds of photos or thousands of photos, depending on the method that we're doing. And we need to turn that into something useful. So what we came up with through a project in the National Environmental Science Program with partners on the ground at Aquanunctum on the West Coast and Cullen Enterprises in Central Cape York was a step-by-step guide to systematic feral pig impact modelling, monitoring for wetlands. And we came up with 6 main steps that would enable that automation piece to occur, but also to enable those values to be defined and then be placed in the context of the data that you're collecting and the management actions that you're doing. So I'm just going to go through each of those steps with an example of how it was used on the ground on Cape York. This is the west coast of Cape York, the APN management area, to the south of the Archer River. So the step 1 was the desktop waterhole typology and management units mapping. We needed to know why we were managing units, the values for each of these units. So if you click on any one of these in the interactive dashboard, zone 1, 2, 3, up to 16, each of them will have their own values associated with it. It'll have a little bit of information about the density of feral pigs, how hard it is to get to, and what the seasonal values are across time. This is based on work done with traditional owners and rangers on the West Coast. We worked with the Department of Environment and Science to say we need to understand what are the underlying ecological values that are driving feral pig distribution to begin with. When we first started doing this work, what we found was that there was a real disconnect between what you were measuring and what it actually meant ecologically. You could go out and measure 50 different water holes and you could get this really messy data set that came out the other side, which wasn't really related to feral pig impacts, because what we were comparing was very different waterhole types, some that dried out early, some that stayed permanent the whole time, some that had food in it, some that didn't. So really, in the first instance, you need to define the values that you actually care about, but also how they're partitioned across the landscape. So you can start measuring apples with apples here. And this is a waterhole type map, which was in the context of how feral pigs see the world. How much food it's got, how much water, how much shade, how close it is to other waterholes of the same values. So once we've done that waterhole mapping exercise, we could go out and actually measure how that actually stacks up in real life. And again, like I said, if you look at this wetland map here, there are thousands of wetlands right through this whole area. If you look at a close up here, there are tons of them. They're all very different, but you need to work out how you're going to measure the impact across that entire landscape. So in the context of practicality, again, we created this very cheap CASA approved camera rig, which we could attach a GoPro or here a Garmin Verb. And again, we jumped in the helicopter, we set ourselves a flight path, and we flew across as many wetlands as we could squeeze into a day. And what that allowed us to do was within the types, we could go back and have a look at it and say, out of all of the permanent or near permanent waterhole proximal to shade and preferred consumptive food plants, that's one of our categories. So this is a gold for pigs. We should say a pig preference of 5 out of 5, a pig damage score of 3 out of 5. So what we can do with this, we've got this for every waterhole type, we've got it how preferable it is for pigs. We should also assume that that has an area that has high pig preference, that has populations of pigs around it, is going to be highly impacted. So for this one here, there's a good reason why it's not a 5 out of 5 pig damage, is because we put a fence around half of it. So it's only 3 out of 5. So there's a real reason why this one hasn't gone out. If you looked at then the distribution across the number of those sites selected, there's 64 of those. The average pig score is, pig damage score is 3.3. So towards the higher end of the spectrum. So once we've got all of that data, so that broad scale information, which is really simple metrics, it's like how preferable it is for feral pigs, and then how much damage is in each of those, how does that distributed across the landscape? You can actually look at where your roads and tracks are and select several of those waterhole types to go through and do some more intensive surveys at. And the intensive surveys aren't going out there and measuring them by hands, it's just using a drone. So we've selected our sites, and then we go out and survey with a drone. So what we've come up with is a set of suggestions on about how to do this. We use a bit of software called Drone Deploy, which is an app on your iPhone, your iPad, or your Android, and then it's mixed with a web app on your computer, which means that you can actually preset all of these surveys on your computer. You can then download that onto the app, and when you get out there, it's all cached on there. So when there's no internet, you can actually still run these surveys and get some detailed information. The important part, as you can see here, is if you do the survey the same way each time, you do that at a very high resolution, you can actually start to see the difference between where you've got a management intervention, like on the right, where we put a fence around it. This is in October 2017, when you'd expect the place to be trashed, versus somewhere where we didn't have any intervention at all, and the place is trashed. So you can start comparing apples with apples, like I said before, and say, we put something in place, it worked, or it didn't work, we need to do something different. So that's just the visual amenity of that. So what you can actually see, and that's often good enough for people. You might not need to go any further than that, but we have built the automated analysis software for the back end, which then can be defined or contextualized against the type of action you put in place. So here we have a few management actions that are commonly applied out on that part of the world. There's aerial culling, there's ground shooting, there's hunting, there's traps, there's fencing, and then there's poison baiting. All of these are logged through some apps that we developed in conjunction with the rangers, so that we know what the effort is, where people went to, and when they did it. That's the feral management actions that we can use to refine how, or to actually look at how well those actions were turning into protecting values. So we get to the last step now, and it's step 6, reporting and adaptation. So we want to take that data, we want to put it into some sort of summarized form, and when we want to use that to adapt what we're doing, or to at least better understand how effective some of that work is. And you can see here for the action, a lot of the activities around the west coast of Cape York have been culling, aerial culling. So we have really detailed data on where those pigs were shot across time. So this top graph here reflects the number of pigs shot across time. The bottom graph reflects how much effort has been put in. So you can see whether or not there's a relationship between effort and numbers shot and how that relates. You can see this huge drop off here in 2020. And then there's a perception that, you know, or sometimes in the past people have gone, oh, look, we're winning. But when you can compare that directly to effort, you can see there was a dramatic drop off in effort in that year as well. So you can actually then start to say, actually less effort was put in. That's why there's a dramatic drop off in pig numbers. You're also then taking that, with all that log data about effort, you can say in each management zone, how much money did be spent, who did that work, and how was it distributed across time. That's related back to the energy and time and money that you have to spend to do things. You can start to do some of those things that Andrew was talking about before. You say, how many pigs do we think were there at the start? You can do some density estimates that we've done doing aerial surveys in areas where we've got good detectability, but then also using some of those fantastic methods that Andrew described before with using camera traps. If you've got a starting pig population, you can start to play around with how many you need to kill. And then that then demonstrates why sometimes you're not actually winning. If you can see the recovery rate here, if you take out 8% from 3,900 pigs, basically within 2 years, you've actually got more pigs than you started with. So there's all of these lovely models that we can actually put into visual sense. So once you understand what the information is, you can actually go in and play with it and say, how many more do I need to get before I can actually make a difference? And then finally, of course, you've got that information you collected in that really detailed information about that wetland. And here it's broken down into habitat types. Where is there open water? Is it dirty or is it clean? Is there pugging or is there cover? And there's some really basic habitat values that then you can actually look at proportionally across time. And you can see here, you can change the date of flight. So the more flights that you do at the same time of year, you'll start to log the changes across time, and it's contextualized with then, have you put a fence up? Have you done some shooting? Have you done some poisoning? And that's the adaptive process. You can actually look back in time and say, hey, we've spent a ton of money and we're not getting anywhere. And here's an example of one of those such sites where we had a lot of generalized aerial culling going on in this region. And what we found was that there was, no impact. So all of that money that was being spent on that area wasn't leading to big impacts on the ground. So the main thing to consider here is that there are some really good publicly available software now where Healthy Country AI is available for people that want to use it. And about 90% of those structures don't change as you shift around. It's just what you pointed at. About 10% of it changes the suit values. So what are the wetland impacts versus cropping impacts? It's really just a different vision problem that you start pointing the AI at. But all of the data management piece can remain the same. It's putting some structure around that from an operational perspective. And just to finish up, one of the big things that we've found is that it's not good enough just to have technology. People need to engage with it. And this is a program that Ricky and I are now putting our back behind for Northern Australia, which is how do we actually get these tools into people's hands, but also how do we build out the entire training and support functions that enable people to use them and interact with them. Thank you.
Thanks very much, Justin. Again, a lot of information packed into that presentation.